building them. Okay, before building, you sync the code, then build them, then you do testing of this code. After testing, you deploy. Based on your requirement, you can write other steps, other stages as well in this pipeline. That is completely up to you. This pipeline actually executes your commands only that you want to run on any stage. So this actually this only can be run when you have all components connected together, right? Like you need to have GitHub connected to your Jenkins. Jenkins is responsible for running your all pipelines. Your Jenkins need to be connected to their slave nodes. Slave node need to be connected to your endpoints, end servers, containers, repos, artifactories where you want to store your code. So this continuous integration makes makes communication between all tools possible by integrating them together. Then comes continuous deployment. In this stage, the code is built. The environment or the application is containerized and is pushed to the desired server. If you are involving container deployment, so your container images will be built in this stage itself. Even if you're not using containers, your build code, your jars, your war files can be further pushed to the server's target machines and they can be run there itself. So both are supported in this pipeline. Containerized or non-containerized application can be built and deployed on the server. So pushing onto the desired server means copying the jar, war files or container images to the target machines where you want to deploy your code. The key process in this stage are configuration management, virtualization and containerization. Suppose you want your server, your target machine, your target server need to be capable of running some application server or web deployment. So that server, suppose it is a VM. We have a VM and we want it to be capable of running applications or website. So to running a website, I will need an application server, right? This application server can be Tomcat, can be WebLogic, and to route the traffic to these application server, we may need a web server also. So my target machine, my virtual machine need to have these servers pre-configured, pre-installed, so that I can deploy my jar or war files on them. So this part is again done automatically. We do not have any admin like previous stages to get my VMs ready and get my WebLogic, Apache or Tomcat installed. This will be again done by my pipeline, my Devops tools automatically. How? This will be done under configuration management. Configuration management will do configuration of the servers as per our application need. Then comes virtualization. Virtualization is again creating your virtual machines so that you can configure them for application deployment. So we can use either virtualization or containerization. Both can be managed automatically using various stages in pipelines without any human intervention. We need to define code. We need to build pipeline as a code where we need to put all the commands that will be run as part of configuration management, virtualization or containerization. So this is part of continuous deployment. More details we'll be covering when we discuss about specific tools, like we discuss about Ansible in configuration management, we discuss Docker about containerization, and we discuss Jenkins about pipelining stages. Once continuous deployment is done, we can do testing. If deployment is done on a testing server, of course, before releasing to production, we need to do testing part. So first we will deploy our code to testing servers so that so the automatic testing tools can evaluate the software for bugs, for features, for requirement fulfillment, and then they report the feedback to developers in case of any improvement needed. The stage deals with automated testing for the application pushed by the developers. If there is any error, the message is sent back to the integration tool. This tool in turn notifies the developer for the error. If the test was success, the message is sent to the integration tool, which pushes the build on the production server. So this is our typical continuous testing. thing that this stage performs. Then comes continuous monitoring. Suppose your testings are getting done, or maybe your production system is running. Both need to be monitored. This stage continuously monitors the deployed application for bugs or crashes. If it is monitoring testing server, it will again pick the errors, pick the feedback from the testing tools, and notify the developers about the bugs reported, so that they can work on the further improvement of the software and release the improved product. If it is running in production, it will be able to capture the errors, crashes, or load on the system that can be notified timely to the support team, and they can take timely action to avoid any unnecessary downtime to the system. It can also be set up to collect user feedback. The collected data is sent to the developers to improve the application ultimately, if this is related to the application code. So this is how these 5 stages help running DevOps successfully. Every tool has a support tool available to make that respective stage efficient and possible in DevOps area. This will be discussing in coming slides. So next session, this is all about working of DevOps, how these 5 continuous things helps DevOps working possible. Now in next session, we will be covering DevOps tools against various stages that we just covered. So let's meet in next section. Thank you. Bye. Hi. So in Introduction to DevOps, till now we have covered why DevOps is needed, what is DevOps, and how DevOps works. Now we will see how DevOps tools and what DevOps tools can be used to make DevOps working possible. We have discussed the DevOps methodology, but this methodology can't be put into action without its corresponding tools. So let's discuss the DevOps tools with their respective lifecycle stages. We have, because of open source nature of DevOps, we have a lot of open source tools available to support our daily working or DevOps working. We have licensed tools as well. Based on the requirement, we need to pick up and deploy those tools in our environment. Similarly, we have Git as a very popular and efficient tool to support continuous development in terms of version control system. Git is a distributed version control system for tracking changes in computer files and coordinated work on those files among multiple people. It is primarily used for source code management in software development, but it can be used to keep track of changes in any set of files. It actually checks the changes in the files that you are adding in the tracking by the by the Git. So this way, Git helps you managing the changes and changes you are doing in the code or in the files. So that's why it is very popular to manage the codes stored in distributed manner. Why distributed? Because developers are working at different places, distributed places, and Git is responsible to manage their distributed codes at one place so that they can be accessible to anyone from any location. That's why this is called distributed version control system. Similarly, we have Jenkins available for continuous integration. Jenkins is an open source automation server written in Java. Jenkins helps to automate the non-human part of the software development process, where you don't need human involvement, and that part can be automated with continuous integration and facilitating technical aspects of the continuous delivery. Jenkins helps all the components that are involved in your continuous deployment or delivery that need to communicate some or other way with each other. Be it developer, be it continuous development, be it Git, be it any version control system apart from Git, be it testing phase, be it monitoring phase, be it deployment to any other endpoints, any target servers, Docker containers, Kubernetes, anywhere, any tool can be integrated with Jenkins, and we can involve and improve our continuous deployment of the software automatically. So this is how Jenkins can play a very crucial role in DevOps working. Similar to Jenkins, we have many other tools available. We have Octopus, we have GitLab. So these kind of tools provide similar features based on our need. So In Jenkins, we create a pipeline to serve our stages as I explained earlier. When we discuss Jenkins in this tutorial series, we'll be discussing more about it. For now, let's understand Jenkins helps. Jenkins is a very crucial tool. Jenkins or any similar tool is a very crucial in our DevOps working, and that provides integration between all the tools that we are going to use in DevOps lifecycle. Next comes continuous deployment. Deployment means pushing your code to the endpoints so that users can access them. Pushing does not involve just copying the code. Pushing needs the compiled code to be deployed on the application servers or similar softwares which supports reading and understanding the working of that code, so that these code can be executed like jar files, war files, can be provided an environment where these codes can execute and provide the functionalities needed to the end users, like deploying a website using war file. So now these deployments can be done on various targets, applications like application servers, be it Tomcat, Apache or WebLogic or similar softwares, and these softwares need to run on some machines. They can be virtual machines or containerization or containers or any other type of bare metal machines as well. So nowadays we are mostly focusing on virtualization or container machines. Containerization, we are not using bare metal machines, but yes, continuous deployment can be done on any kind of endpoints. It can be network device as well. It can be storage. It can be Linux. It can be Windows. It can be any kind of flavors. You can do your deployment. Similarly, the second part of continuous deployment is, rather I would say it first part, because before deploying your software, you need to configure the server, configure the target endpoints. So the target endpoint can be configured in configuration management stage. There are a lot of tools available like Chef, Ansible, Puppet to support configuration management of the target machines. It can be server, it can be network devices, it can be containers, it can be container images. So it can be, the target can be anything. Now it is every DevOps support almost all kind of endpoints that can be configured automatically, and deployment can be made possible on them without any human intervention. So this is how continuous deployment can be done using these kind of tools. So configuration management can be managed using tools like Salt, Puppet, Ansible, Chef, while containerization or virtualization can be used. Like for containers, we can use Docker, we can use Kubernetes. Similarly, for virtualization, we have a lot of virtual machine like VMware softwares, we have Oracle VirtualBox, we have cloud service providers available now like Amazon, we have Azure, we have Google Cloud. So these kind of platforms can be used for virtual machines, instances that can be provisioned in a minute automatically by your Jenkins or pipelines, and then your software can be deployed on top of them. Next comes continuous testing. Selenium is kind of software that is a portable software testing framework used for web application. If you are developing a web application, Selenium is a tool that helps you testing those codes automatically. It is an open source tool which is used for automating the tests carried out on web servers. These web applications can be tested using any web browser once they are when the test cases are run against the code. You need to write your test cases in form of code, and these codes will be run. These codes will be run during the testing phase by the Selenium. So obviously, Selenium code format you need to use while writing your test cases. Similarly, other tools are available based on the different types of application you are developing. We have JUnit, we have other supported tools that you can use based on your requirement to make continuous testing possible. Then comes continuous monitoring. Nagios is an open source DevOps tool which is used for monitoring systems, networks and infrastructure. It also offers monitoring and alerting services of any configurable event. So Nagios is one software that we can use in continuous monitoring. It monitors almost everything that you have, from your server systems to network infrastructure and application. So this kind of monitoring the continuous monitoring can be performed using Nagios, while we have other softwares also available in market, like we have Prometheus. we have Grafana for dashboarding of the logs pulled by Prometheus. They can be used together. Nagios we discussed already. We have complete ELK stack, Elasticsearch, Logstash, and Kibana that again can be used to monitor. We have Dynatrace for application monitoring. So there are various tools available that we can pick and use as per our need. They help you monitoring. They help you monitor the deployed software, share and sending the feedback to the developers for further improvement in the application. So this is again placement in the same diagram that we discussed in working of DevOps. Like we had version control system, now we have placed GitHub here. So GitHub will serve the need of version control system in your environment. Then comes continuous integration. So Jenkins is helping you to manage the continuous integration between various devices and systems. So Jenkins can be used to integrate your various systems for testing server or production server or even cloud machines. Then you have a Puppet or Ansible or Salt in order to support configuration management on the testing servers. Selenium is there to support continuous testing, and Nagios is there to support continuous monitoring needs. So this is how these tools collaboratively helps manage DevOps working and making DevOps possible. You have a lot of choices. As I said earlier, you can pick the tool of your choice and make DevOps working possible in your environment. I have tried to put more tools that can be used in order to support your DevOps working. So like we have planning, code base, building, testing, stage. So for planning and code base, like for continuous development, we can use Jira, Git, softwares collaboratively in order to support. Jira is again used for managing your code. We have Bitbucket similarly that can be again used to store your code and performs and support same operations as Git. Similarly for continuous testing, we have various software. Like for building, we have Gradle. We can use Maven for Java codes. Okay, then for testing, we have Selenium, we have JUnit. Similarly for integration, we have Jenkins, Bamboo, Travis CI, we have Octopus, we have GitLab. These all support same kind of features to provide you continuous integration among the various tools. For continuous deployment, we have for configuration management, we have Chef, Puppet, Ansible, Salt Stack available that I named earlier as well. For monitoring and operation, we have for monitoring, we have Sensu, Nagios. Okay, so these kind of Prometheus, these kind of tools we have in place, and most of them are open source. If we don't want to use any support provided by them, so they are open source and we can use them for our DevOps needs. So this was all about DevOps tools that you can use to make DevOps working possible in your environment and make your IT much faster than you have it currently. So thank you for this first session. In this session, we have covered introduction to DevOps from why DevOps, what DevOps, DevOps working, and DevOps tools perspective. In next session, we will be starting with the specific topics. Till then, thank you. Bye-bye.